So now we will start the meat of our course. And so what we really need to do is make sure everybody's on the same page regarding evolutionary theory. I mean, this should be the fundamental takeaway from high school biology, if you've had that. But evolution is certainly getting a shaft lately. There's been a somewhat political battle to try to discount evolutionary theory. And so we're going to make sure with this first lecture that you guys understand the principles of natural selection and also the principles of actually doing science. We will start by enumerating the naturalistic fallacy. Now, if you search on something like Wikipedia or you've taken philosophy classes, there are several different ways that we can frame the naturalistic fallacy, but we are going to take the approach that David Hume used and talk about the is-ought confusion or controversy. And so we will define the naturalistic fallacy as the confusion of what is with what ought to be. The is what we really are trying to measure, what exists, the ontology, and why it has occurred, the cause and effect. The ought refers to the desirability or the moral value of the outcome. And so, unfortunately, because this course and a lot of the work, well, obviously the work that anthropologists do, is addressed towards studying humans, we have a really difficult time separating this ought, the desirability or moral value of what we were studying, from the is. And so, why? Why are we particularly vulnerable when we're studying our own species? Well, people have a personal interest or a bias in what's invested in the answers to some questions. So, for example, if we're studying efficacy of medications and we see that the study is funded by a pharmaceutical company, we may question the ethics. We may question whether there are any inherent biases in how that study is being done. We certainly fall prey to the same kind of bias and temptation when we're talking about the evolved nature of human behavior. Certain answers may serve personal interests better than others, and so we can study or look at funding and lobbying with respect to the development of scientific standards. And when we see that religious organizations are making large donations to lobbying efforts, we might have the expectation that science policy might change. Nowhere is this more perhaps evident than in the current composition of some of the most recent president's cabinet picks. For example, the attempt to dismantle the EPA, appointments for the Secretary of the Interior that are interested in opening up protected lands to commercial concessions like oil and gas and mining, etc. We also have this tendency to refuse to accept certain answers even in the face of overwhelming evidence. And so there's been a lot of talk among scientists of late that really started to come out with the March for Science effort last April, that this idea of how do we effectively communicate science to the public. And we've seen these kinds of questions surface with regards to attitudes toward climate change, for example. We have political leadership uh, currently at the federal level that quote unquote doesn't believe in global climate change, that tries to frame this as natural climate cycles. And just showing people the data doesn't seem to work in terms of trying to change behaviors, trying to change opinions. In fact, if we over present data to people who are questioning, we can often derail the conversation. We can often get people to the point that they simply throw up their arms and refuse to even engage. And so we really have to be careful as scientists in how we frame the questions, how we communicate our findings, and not to come across as some know-it-all who thinks they're better than someone else. So, why do we then want to apply an evolutionary theoretical basis or the evolutionary theory to the study of human behavior? It's because we want to measure this what is. We want to understand the causality of certain human behaviors so that we can better affect change. So we may look at the causality of overconsumption, for example, conspicuous consumption, over packaging, over buying, a disposable kind of lifestyle, and we may reflect on the fact that it's an advertisement of status. And what is it that individuals get out of status? Well, typically males respond more strongly to it than females, and it's mediated through greater reproductive success, greater access to mates. So if we want to understand if we want to be able to change a particular pattern of behavior, we have to understand why it occurs. We have to understand the causality, which requires allowing all possible explanations to be assessed with evidence. So how do we combat the naturalistic fallacy? The naturalistic fallacy, this is alt problem. We've got an overwhelming human tendency to apply it, particularly to these studies of ourselves. Well, the best way to combat the naturalistic fallacy is through practicing good science. So we will briefly talk about what makes science good science. There are three basic principles of science. The first is this reliance on public versus private information. For good science to be practiced, we need to have the ability for people to see your data, the ability for people to even perhaps reanalyze your data. And so you should be skeptical of any kind of research that's out there where those data are unavailable. Science relies on this public nature of the information that's being shared. The evidence in support of a statement must be replicable by gathering independent information. So particularly if we are making any inferences into causality, we need to be able to gather independent data sets that demonstrate those same cause and effect principles, and that will be able to then yield similar results. And then those statements about cause and effect principles must be generalizable to other situations in which the same cause and effect principles should be operative. So, with respect to paleoanthropology, right, we may look at chimpanzee society. We may look at chimpanzee tool use and make conjectures as to what early hominins would have been like, and we can discuss how appropriate this is given what we see present in the fossil record, and what we know about the climate that fossil hominins occupied. So these ideas that we're going to present, these ideas we're going to analyze, in this course we are often going to talk about well-documented theories of behavior that exist across taxa. So when we talk for example, about sexual selection and the elaborate ornamentation that we often see among males. We won't just talk about human males. We will talk about prairie chickens. We will talk about crickets. We will talk about baboons and mandrills. And these kinds of generalizable cause and effect principles, when they apply across taxa, they're that much more robust. So a lot of the evidence that we will use will start from an animal basis and then expand into subsistence economies, particularly hunter-gatherers, and then we might make conjectures about how those sorts of principles change in a modern context. What are the goals of science? Well, science first and foremost wants to answer questions. And these questions can be either descriptive or explanatory questions. So a descriptive goal, we will talk about the Ache a lot in this class because we have over 30 years of data collected on the Ache. They were a very well-studied tropical American foraging population that at that point of contact still used stone tool technology. So the data that we have from the Ache looks at these kinds of more typical or even primitive foraging behaviors of this group, and then looks at how their life has changed with this settlement into reservations at the hands of missionaries and government officials. So one of the things that the Ache were notable for was the frequency of divorce. The average postmenopausal female among the Ache, by the time she hits menopause, would have had about 12.1 spouses. This is a fairly large number, even when we compare across hunter-gatherer groups. The Hiwi over in Venezuela only have 1.2 spouses. The Kung are around 4 spouses. The Hadza are around 5 spouses by the time they hit menopause. So a descriptive question could be, what is the divorce rate among the Ache? Or conversely, we could look at foraging behavior. The Ache are unique in that when they're on forest treks, they share everything absolutely equally, so that the hunter and his family get no more of a share of meat or even collected items than anybody else in the group. So we might ask, how much do the Ache share food? Explanatory questions get at this cause and effect. So we could ask, what specific factors determine the Ache divorce rate? What is it about the Ache in particular that makes their divorce rate so high when compared to other tropical foragers? We might also ask, looking across a variety of populations, what determines variability in divorce rates among hunter-gatherers, among people, or even among species. Now, we don't have formal marriage among other species, but we do have long-term pair bonding. And songbirds, for example, are notorious for both pair bonding, but also then the degree of infidelity that they have while pair bonded. So what guides this third principle of science is the principle of uniformitarianism. And so when we talk about the ability of science to be generalizable, to be able to make the same inferences across different contexts, this relates to this principle of uniformitarianism. The idea that we as scientists expect for similar causes to produce similar effects. It's very important when we're looking at cross-cultural comparisons. So, for example, the set of decisions that people have to make when they're deciding what game to pursue while hunting, or how long to spend in a particular patch while gathering. We would expect, if we have a good theory of foraging behavior, we would expect that the similar sorts of questions would be faced across a variety of cultural contexts. It's also important when we try to make inferences about human evolution. And so looking at for example, early hominin behavior, we often generalize or make comparisons with great apes, with the expectation that because early hominins were very similar in body size, very similar in habitat to great apes, very similar in brain size, that many of the behaviors that they demonstrate would have been similar. And so what these pictures represent is generalized tool use. So we've got chimpanzees at the bottom using tools to process collected resources. We've got a human population here at the top using tools to process gathered resources. And this expectation that if modern humans are doing it, if chimpanzees are doing it, then we can make that same sort of inference about the ability of fossil hominins to do it. So to practice effective science, we need to meet a couple of criteria. We need to first have a clearly framed question. Now remember that question can be descriptive or explanatory. We need to have hypotheses to answer that question. And so we need to say that if we see a change in A, we expect to see a change in B, that certain causes will yield measurable effects. We need to clearly operationalize our variables. So we need to determine what our dependent and independent variables are and what the nature of their relationship will be. We also need to determine how we are going to collect our data, what kinds of values are we going to attribute to our variables, what's our data collection scheme, etc. This requires then methods for measuring these variables. So if we were looking at Achet divorce and we want to measure how variations in ecology or nature of food resources impacts divorce. Do we want to measure divorce as a binary variable? Yes, no, you got divorced. Do we want to measure instead a continuous variable in terms of the tenure of the relationship? How long did that relationship last based on these dependent variables? We also need to then have a mechanism for interpreting the results, and that is what is driven by our overarching theory. Now, the word theory is kind of a loaded word with respect to science, because when we talk about theories, and scientists bring up something like the theory of evolution or evolutionary theory, you'll often hear as one of the criticisms regarding evolutionary theory is, well, it's just a theory. And this involves some misunderstanding of how we would define a theory. Many times people mistake or confuse hypotheses for explanations. They confuse that with theories behind interpretations. And so when we say that something is quote unquote just a theory in science, we mean that it's been well tested, that it's been generalized to multiple contexts, that there's a robust body of evidence that's supporting it. We're not hypothesizing something when we invoke a theory. So one counter to that statement of, well, it's just a theory, is that so is gravity. That Newtonian physics, this idea behind the theory of gravity, you're not going to go jump off a bridge because you disbelieve in gravity, nor are you as an individual or as a species going to stop evolving just because you disbelieve in evolutionary theory. And so we will define theory as a set of principles regarding causal connections between variables that unites previously unconnected observations in a common framework and which makes new predictions. This is one of the powerful aspects of a theory, is its ability to make new predictions about previously unstudied relationships in a fashion that can withstand the scrutiny of empirical observation. And so, we're not looking necessarily to establish scientific fact. I mean, evolution is scientific fact. We measure measurable change, but that can't, in and of itself, make predictions about how future change may occur. The theory behind evolution and what we call evolutionary theory is the theory of natural selection, the mechanism by which evolution occurs. And so this is really what gives us that predictive value. And so if we're clearly framing evolutionary theory, we would talk about the theory of evolution by natural selection, with natural selection being the mechanism. So we will discuss in great detail evolutionary theory, but we will also talk about other theories. We'll talk about kin selection, sexual selection, sex allocation theory, life history theory. This is another critical one that is concerned with the timing of life events, particularly those that impact mortality and fertility. We'll talk about optimal foraging theory, reciprocal altruism. All of these are theories about behavior that have hundreds of implications and apply to all living organisms in their general form. So, for example, when we talk about reciprocity or reciprocal altruism, we'll look at reciprocal relationships in other species before we talk about reciprocity in humans. And so the very nature of these theories means that they can apply to a variety of different taxa, and that is the strength in what we define as a scientific theory. The fact that it can generate predictions, the fact that it is generalizable across taxa, etc. When we practice science, we have three general methods of practicing science. We have the comparative method, where we can make comparisons across current or across discrete groups and control for certain variables, but look at how key outputs or key dependent variables change. And so, utilizing the comparative method, we might compare across species. So, we might make a comparison across chimpanzee hunting behavior and human hunting behavior. We might make a comparison across Hamadryas baboons, who are very much harem organized, and gorillas, who are also very much harem organized. We can make comparisons across cultures. So we could look at divorce among the Ache and compare that to divorce among the Hiwi. We can compare across individuals within a culture. So we may look at the fertility decisions of women who are early on in their reproductive career, let's say between the ages of 15 and 30, and fertility decisions of women who are towards the end of their reproductive career. So let's say between the ages of 40 and 55. We can also look across contexts within individuals. So regarding that, those decisions made about fertility, we could do longitudinal studies of women from the onset of reproduction or reproductive capacity at, let's say, about 15 to the cessation of reproductive capacity at around 50 or 55, and compare how women's decision-making processes change over their reproductive career. The problem with the comparative method is that we have very little control. So we hope that we are controlling for relevant independent variables, but really we're not able to perfectly control for everything. So we may see. For example, that here we thought we were controlling for educational attainment, but in fact it was a confounded relationship with socioeconomic status. We just don't have the ability to either control for everything perfectly or to manipulate variables. When you're comparing across contexts, you're not able to go in and experimentally change things. Many of the studies of humans in particular, we wouldn't be able to experimentally manipulate things because of the kind of ethics behind working with humans. We also could utilize the experimental method. This gives us great scientific control in terms of we've got a perfectly set up controlled environment where we manipulate only one or maybe two variables at a time and then measure the change in the outcome based on those manipulations. However, particularly working with humans, this can be impractical, immoral, or artificial. There's a lot of psychology experimentation that's being done within the lab, and one of the big criticisms of psychological research is that these conditions are often incredibly artificial. How can we expect people in the lab to make the same decisions utilizing the same criteria as they might out in the quote-unquote real world? Similarly, some of the questions that we may want to answer, we can't ethically make those manipulations. So, for example, if we wanted to measure the effect of one additional offspring on the investment that existing offspring get, we can't randomly assign people certain numbers of offspring. So to really measure the effect of that outcome, we would want to give a certain subset of families an additional offspring. We can't just go around to people and say, here's a baby for you. So we may only see that additional offspring introduced based on very personal decisions about whether it's appropriate or not appropriate to reproduce at that time. So we can't do a lot of the studies that have been done in animals, manipulating like clutch size or manipulating paternity or such, because we are working with humans. So that leaves the third method, which is natural experimentation. This is where we use naturally occurring change or variation to manipulate variables of interest, then measure the outcomes. And so with the Ache, for example, there was a question of why were the Ache, even as recently as 1979, not practicing horticulture or small-scale farming. And one of the theories was, one of the hypotheses, related to the fact that they were still utilizing stone tool technology. And so a very savvy experiment was done with the Ache, where the anthropologists working with them, Kim Hill, Magdalena Hurtado, Hilly Kaplan, they had Ache men clear a, plot of land that was a certain size, 1 1/4 acres, 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 1 1/4 with first a stone-bladed axe and then on another day, so that it wasn't a situation where they were exceedingly tired from already having cleared with a stone axe with a metal bladed axe, and measure that time that it would take to clear, because the natural experimentation component here was that longitudinal studies of the Ache had demonstrated that once they were settled into reservations and had access then to stone-bladed tools, that they very quickly made that shift to small-scale farming and community gardening. And so by noting that naturally occurring change, then Kim Hill, Hilliard Kaplan, and Magdalena Hurtado were able to fashion an experiment that was able to really kind of get at that causality, and confirm that yes, the mechanism that was driving this change in behavior was in fact what they thought.